can you see over here, general input? So this general input is for whatever elements we are going to design or model over here. Let's say over here there is a shell element, right? This is cylindrical shell. So let me delete all. And start with a new one. So now we are not having anything, correct? So you have to click upon the element to be deleted. You can use the delete button from your keyboard, or you can use this delete option. So let's say I'm selecting this, delete, enter, delete, enter, delete, enter, and then Control Z as undo. So it is showing me these components. So let's say there are no components over here. We are into general input. So I want to create one vertical vessel with a cylinder. So I need to click upon this option over here. In elements, these are called as parent elements. I have just chosen cylindrical option, correct? So you can see over here, cylinder has been created. So under this general input, you need to give all the information to design this cylinder. Let's say I have to give the name shell course -1. So I can write it over here. Shell course -1. Then the node number 10 to 20. It's a cylinder, right? The diameter basis is inside diameter. What is the diameter? Let's say 1000 mm. What is the length? Based upon the market availability of the plates. The plates are available in the market in the widths of 1250, 1500, 1800, 2 meter, 2.5 meter, 3 meter. So these are the available plate widths. So if I am the manufacturer, if I am going to buy 1500 mm plate, so I can put this as first shell course element as 1500. Is it clear? Then the finish thickness and nominal thickness. These are the thicknesses that you need to enter at the last, because you don't know what the thickness required coming over here, since you haven't given the corrosion allowance, material of construction, joint efficiency. So that is going to get changed. So don't put finish thickness, nominal thickness in first go. Enter corrosion allowance. Let's say in our case 2 mm is corrosion allowance. So I'm putting 2 mm over here, right? Make sure you have chosen ASME Section Division 1 and ASME Unicode as the unit. Let's say there is no external corrosion allowance. Wind diameter multiplier. So in wind diameter calculations or wind calculations, you will see this. So wind diameter multiplier. Many a times it happens that your vessel is connected with so many pipings. So in PV you cannot model all the pipings, correct? So what you are doing, you are converting that piping area, whatever is directly connected to your vessel. Let's say there is some pipe which is coming like this, and it is having 10% of the area of this particular shell. So you can multiply the shell diameter, or you can multiply it with a multiplier, so that the area which will be used in the wind force calculation will be based upon this multiplication to the diameter. So now the diameter which will be used in the wind load calculation will not be 1000 mm plus 5 plus 5, 10. So it will be multiplied by 10%. So if you click upon F1 over here, wind multiplication diameter or wind diameter multiplier. So what does that software tell us? Can you see this? Wind diameter multiplier. Enter the wind load multiplier diameter. The value is multiplied by the element outside diameter in order to determine the overall diameter to be used in the wind load calculation. The element outside diameter includes the insulation. When using a number greater than 1, carefully account for the tributary areas of the external attachments such as nozzles, piping, ladders. The typical multiplier used to determine the wind load multiplier is 1.2. Thus, the actual element OD, let's say it is 50 inches, the overall wind load diameter would be 50 multiplied by 1.2, which is 60 inches. So, it is going to increase the diameter by 20%. The value of the wind load multiplier diameter can be as low as 0. अब ये 0 कब होगा? When it can be 0? If let's say you are having one building and if your equipment is to be placed in a building and half of the portion is coming outside the building. So the portion which is inside the building will not face any wind. So there it should be zero load, correct? Portion which is coming outside the building will be having the wind load. So for that you can have 1.2 or 1.1, whatever the multiplier. For the components which are inside, you can have it 0. If the value of 0 is used, there will be no wind load that will be applied to that particular element. Is it clear? So this is what this 1.1 or 1.2 wind diameter multiplier is. Then comes the material of construction. Let's say if we are having material as SA 516 grade 65. So you have to type SA, then space 516 space 65 and then hit enter. So it can choose the material directly. But if you want to select it from the database, let's say I am deleting 65 from this. I am just putting SA space 516 and hitting enter. So it will take me to all the options available under SA 516. Can you see over here? 55, 60, 65 and 74 options are there. So I can choose as per my requirement. Let's say I want to choose SA 516 grade 65. So I can click upon 65 and then select material. So it will show you all the properties. You have to hit OK. Again, you have to hit OK. So now the material has been chosen over here. Can you see over here? All of you have done this. So if you click upon this and go to properties, it will show you what is the allowable stress value at ambient temperature, at operating means design temperature, hydro test condition allowable stress value, what is its yield value, then UTS ultimate tensile strength value, etc. Can you see over here? So this is the allowable stress value at the ambient temperature, means normal temperature 40 degrees Celsius. This is the allowable stress value at the design temperature what you have given over here. Here it is 128. Then this is the allowable stress value at hydro test condition. This is yield strength value. This is ultimate strength value. This is material density. Okay. Then you can have the joint efficiencies, LSIM and CSIM. Can you see over here 3 dots? If I click upon these 3 dots, it will take me to this new window. There are also 2 tabs. Can you see longitudinal weld sim data and degree of the radiographic examination and PWHT. By default, it will be under degree of radiographic examination and PWHT. So here, if you know all the code requirements, you can choose it from here. If you are having spot radiography, you can choose this. There are types of weld, type 1, 2, 3, 4, 5, 6, 7, 8 and 9. So based upon your type of weld, you can choose this. Let's say it is type 1. Let's say this is spot radiography type 1. So for spot radiography, your joint efficiency would be 0.85. How much? 0.85. If you know spot radiography is 0.85, you can directly put it over here. Or else you can choose it from there and the software will give you the joint efficiency accordingly. Is this clear? For this particular material, if you are going to do any post-weld heat treatment, so you can click over here so that you can see post-weld heat treatment is not required. Here, let's say if we are having a thickness more than 40 millimeter, how much? More than 40 millimeter. Can you see over here? PWST is required. So please check this box on. So for 516, 65 or 70, at what thickness PWST is compulsory? That is given in UCS 56. So that must be known to you. Then only you can be able to use it correctly. So let's say it is spot radiography. Longitudinal weld seam data. Can you see over here? So number of seams. It has considered two seams. If you are having only single seam, you can delete the data from #2. Only in #1 I am having at 0 degree. So hash of seams, number of seams I am having only one. And if I hit upon OK, so you can see only at 0 degree I will be having one seam. Correct? I am having only one seam. So as per your requirement, you can have the weld seams positioned. So if I don't want to have it at 0 degree, I want to have the first seam at 45. I can type 45 over here. So here you can see 0 is where, 45 is where. So it will be going towards the back. So far all of you are with me on these options. Then the pressure. Let's say if you are having 10 bar pressure means 1 MPa. So I have chosen one over here. If you want to have bars Unicode as a system over here, you can put the values in bar as well. Let's say 10 bar. Let's say our temperature is 100 degrees Celsius. There is no external pressure. So external pressure means what? If let's say you are having any full vacuum condition, so your atmospheric pressure of 15 psi will be acting as an external pressure if you are having jacketed vessel. Here we want to have the values for design pressure and design temperature. Now since I have chosen correct material, I have given joint efficiency, I have given correct design pressure and the temperature. Now you can see over here TR. Can you see TR? 6.64. That is my required thickness for that particular internal pressure. So in market, there is no plate 6.6 is available. So either I have to go for 8. So I can put nominal thickness as 8 millimeters over here. So when you are going to do the rolling operation, have you heard about rolling? You will be taking one flat plate, you are going to pass that through the roller, it will change its shape to the circular. So that is called as the rolling operation, by which your cylinder will be manufactured or prepared, right? So in that rolling application or rolling procedure, there will be no reduction in thickness. If I am going to put 5 mm plate inside the roller, I'll get the 5 mm plate only. So there will be no reduction in the thickness. So your nominal thickness and finished thickness both would be same. Both would be same. Is it clear? So here you can see now my required thickness was 6.64. My finished thickness is 8 mm. So this is called as a general input tab. But prior to this, there is one tab which is called as a design constraint. This is very important. We always start modeling with a design constraint and then go into general input. So on the right hand side, you can see design constraint, right? So click on design constraint. So let's say I'm having multiple shells like this. So this is called as a L seam, longitudinal seam. And in between two cylinders, this weld is there, right? The circular one. So that is called as a circumferential joint. So this joint efficiency for this weld would be longitudinal joint efficiency. And for this weld, the joint efficiency would be circumferential seam joint efficiency. Yes. So now we are checking into design constraint options. All of you are into design constraint now? This is the first thing what we need to do. Then we should go into general inputs. Always you should start with the design constraint first. So here by default, the software will show you the default values, what has been setted over there. So if let's say my vessel is having 11 bar or let's say 5 bar as the pressure. So I can put it over here, design internal pressure, which will be 5 bar for all the equipment. So let's say I put 5 bar. So I don't want to put it every time. So if I put it here once, would you like to update the model to reflect these changes? Let's say yes, because we have first created this, right? Otherwise it would not have asked for. Then design external pressure. Let's say our design external pressure is 0. Design internal temperature. Let's say we are having 100 degrees Celsius, which I want for every component to follow. Design external temperature, let's say it is 0. So have you changed this 5 bar 0 external pressure? Temperature is 100 degrees and 0. So can you see this option? User defined MAWP. So this option to be used if let's say you are going to design only some part of the equipment, not the entire equipment. And the other part of the equipment which you have not modeled is having MAWP which is lesser than your vessel MAWP. So in that case, that value can be placed over here. Let's say in case of heat exchanger, the heat exchanger is already in place. It is already functional. Now, because of some reason, its bonnet of one side needs to be replaced. Now you are just modeling that bonnet or channel. Okay. The equipment is already having MAWP, let's say 8 bar. Now the new bonnet what you have created is having MAWP of 15 bar. So are you going to do the hydro for that entire equipment for 15 bar? No. It should be based upon the lowest component MAWP, isn't it? So let's say the lowest component which is already in service, it is at 8 bar. So your new component what you are designed should have MAWP is equal to 8 bar. So there we can put it over here. So mostly it will be done for where you are not having a single model done for the entire vessel, or you are doing only the partial part of the entire model, or there is one component which is or one equipment which is placed over the other. So in such cases, these values to be put. Okay. User defined MAWP and MAPNC. Otherwise, it will always be calculated for the given existing model. Additional operating static pressure. So if let's say there is one equipment mounted over the other and that equipment static head you want to consider in this vessel. So in that case, you can add on that static head. Otherwise, in normal modeling, you don't have to put any value for this. User defined MAWP and MAPNC. These are the options only to be chosen if you are not building entire model in the same PVLit file. If it is broken model, then the lowest model MAWP we have to put it over here. You are having one equipment like this. And that equipment is having saddle supports like this. On top of this, let's say there is one more component or equipment which is been placed. Let's say it's a vertical exchanger or any other equipment like this. Correct?
Yes.
Now, we cannot model these two equipments in a single file in PVLit. PVLit will have a functionality which allows you to model only a single equipment at a time. So now, let's say this is filled with fluid. So I am going to model this equipment. So whatever that fluid is there, I can model that and its static head will be automatically considered. But the same equipment is attached to some other equipment and that equipment is also filled. Ultimately, the static head of the top equipment will also come on the bottom equipment, isn't it? So let's say from this to this, there is a 0.5 bar static head which is coming additionally. If I'm going to model only this equipment, the software will not realizes that there is a 0.5 bar additional pressure to be considered as a static head. Correct? So in such cases, this option can be used, and here you can put that value so that the software will add the static head into your design pressure at the time of designing any component which you have modeled. Is it clear? Then comes the pressure testing options. So now it is very important that the person who is going to choose any of these options should be 100% aware upon the code requirements. If you are not knowing what do you mean by UG99B as per code, what do you mean by UG99C, what is the meaning of UG99B and Note 35, what is UG100? Let's say UG99B uses the equation for the calculation of hydro test pressure as 1.3 into MAWP into static head. So how the hydro test pressure will be calculated? 1.3 into MAWP into static head. That is called UG99B. Then UG99C. UG99C is considering MAPNC. That is maximum allowable working pressure, maximum allowable pressure in new and cold condition. What we have discussed, right? With one example. So it uses that 1.3 into MAPNC. Then UG99B and Note 35. So this uses 1.3 into design pressure into static head, LSR. 1.3 into design pressure into LSR. Instead of MAWP, you can use a design pressure. If you are going to have your hydro test as per UG99B and Note 35. So in your vessels, in design data, you must see that hydro test condition. What was written over there? Can you just show that drawing to me? Can you see over here UG99B end note 35 means what? 1.3 into design pressure into LSR. So 20 into 1.3. Can you do? So that is why it is written 26 over here. Its allowable stress ratio at the ambient temperature to the allowable stress ratio at the design temperature. It is the ratio of these two. So here the temperature is 100 degrees Celsius, right? And is the material carbon steel over here? 316L. So at 100 degrees Celsius, if let me just choose it. I hope you can see my screen. Let's say I'm having SA240 316L. Can you see over here SA240 316? 316 will be having two values. One is with high strength, other is the low strength. When to use which? For flanges, we have to use lower allowable stress values. For other materials, we can have the higher allowable stress values. So here we are talking about shell, not the flange, right? So what is the allowable stress value? 115, correct? What is the allowable stress value at the design temperature? Same. So the stress ratio would be what? 1. Are you getting? So 1.3 into LSR into design pressure. So LSR would be 1. So you were showing that report also. Can you just open that so that we can see it from the report itself? That where it is been given so that you will also better understand.